Unit 14, Part 1. Unit 14's on quantifier form and truth functional compounds of quantifier statements. So the big lesson from Unit 14, I can state very quickly, it is to learn to distinguish...
Hi! To learn to distinguish me.
What?
To learn to distinguish me.
The big lesson is to learn to distinguish when formulas are in quantifier form, so to distinguish statements which are in quantifier form from statements which are not in quantifier form. And the quick answer statement of how to do that is there are two, which I've said several times in previous videos, but this is the Unit 14, it's the big lesson of this chapter. There are two conditions for when a statement is in quantifier form. Condition 1, the statement, the formula, has to begin with a quantifier. Second condition, the scope of that initial quantifier has to go to the end of the formula. Okay, so throughout the entire course, I have been stressing how important it is to be aware of the form of any formula. So all through the sentential logic section, I was saying when you have a string of symbols which may look to your brain as horrible and ugly and complex beyond comprehension, I was always saying, look, if you just ask yourself and answer the question, what is the form of this thing? That is, what is the major operator of this thing? Distinguish it as, say, for example, a conditional, identify the major operator of the big long string of symbols as a conditional. That's the main thing you have to do, because that's what allows you to know how to go about, for example, determining whether the formula is true or false. If you have an assignment of truth values to the atomic parts, I'm thinking of sentential logic here. And when you're doing proofs, that's if you grasp some complex formula as a conditional, that's what allows you to be put in mind of the right rules, the rules that you'll be using on this formula. Oh, it's a conditional. I should be thinking about anticipating the use of modus ponens, modus tollens, maybe hypothetical syllogism, so on and so forth. Okay, so where are we in quantifier logic now? So this is Unit 14. We started in Unit 10. You were introduced to singular sentences, right? Dan is Australian. Uppercase A, lowercase d. Introduced into the elements of this. I have to say teacher is Australian, not Dan is Australian. That's not a singular sentence. A knowledge of quantifier logic is rudimentary at best. Okay, it's fine. Thank you, okay. So we introduced to singular sentence, we had propositional functions and names. Propositional functions, one of the basic elements. Unit 11, simple quantifier statements, how propositional functions are combined with quantifiers to make quantifier statements, right? So remember those simple quantifier statements of Unit 11, for all x, ax, everything is Australian, there exists an x, ax, something is Australian. Okay, just one of the quantifiers annexed to a simple propositional function. Those were the simple quantifier statements. Those are in quantifier form. Notice that they satisfy the two conditions. For being in quantifier form, starts with a quantifier, scope of that initial quantifier goes to the end of the formula. Units 12 introduce you to categorical propositions. Those are also formulas in quantifier form. They also satisfy those two conditions. Chapter 13, the categorical sentences with complex subjects and predicates. Chapter 14 now, which is a very short chapter. There's only 6 pages of text, you'll notice, but it's really just about quantifier form and distinguishing statements in quantifier form from statements which are in truth functional form, which are disjunctions or conditionals or conjunctions, but that have quantifier statements as components. But this is Unit 14. And Unit 14 proceeds and anticipates Unit 15, which is really the climax of this whole section on quantify logic. Unit 15 is when we learn to do proofs in quantify logic. And Unit 14 very much is needed. The lesson from Unit 14, learning to distinguish when formulas are from when they are not in quantify form, is crucial for being able to do proofs. So I want to start the lecture on this chapter, Unit 14, with a look towards where we're going in Unit 15. Okay, so what I have here is a sample proof, right? Which will look like what we'll be doing in Unit 15. So we've got two formulas, two premises, right? Two premises to start and a conclusion, and we're going to have to get to that conclusion. So now I'm going to say a little bit of the content of Unit 15. Shh, quiet guys, okay? Quiet. Which you won't have read yet if you're watching these in the order in which you're reading the chapters, but that's fine. We're anticipating what's happening. So once again, in Unit 15, there all the old rules of sentential logic, the rules of inference, the replacement rules, those rules apply once again, but they only apply they only apply, as they ever did, on formulas that are conditionals and conjunctions and disjunctions, right? You can only use simp when you've got a conjunction, and the form is a conjunction. You can only use modus ponens, modus ponens, and modus tollens on conditionals. Crucial lesson of Unit 14, I'll say it several times. A formula is in one or the other of these forms, right? A formula is either a universal statement or an existential statement or a conditional or a disjunction or a conjunction or a singular sentence, right? Or a biconditional or a negation, right? It is one or the other. So very, very crucial for you to grasp, right, that if a formula is in quantified form, so if a statement is a universal statement or an existential statement, then it is not a conditional, right? Then it is not a disjunction, which means you cannot use those rules governing disjunctions and conditionals on statements that are in quantified form. And similarly, there are the 4 new rules governing the use of quantifiers that you'll be introduced to in Unit 15. Very, very crucial, and this is why Unit 14 is so crucial for 15, very, very crucial that you can only use those rules on formulas that are in quantified form, which means you cannot use these rules, the instantiation and generalization rules, you cannot use them on negations, most crucially. You cannot use them on formulas which are conjunctions or disjunctions. You can only use them on formulas which are in quantified form. That is, formulas that begin with a quantifier and for which the scope of the initial quantifier goes to the end of the sentence. Okay, so what's the big lesson in Unit 14? Distinguishing formulas that are in quantified form from those which are not in quantified form. Why is it so important? Because when you're presented with a proof like this, right, the very first thing you need to be able to grasp, what? You can come and say hi if you want, yes. No, don't turn it around, please, no. No, don't turn it around, sorry. Cancel school. When you're presented with a proof like this, okay, the first thing you have to grasp is that these formulas are not in quantified form. None of them are. Why? Because they are negations. You will be presented with a lot of proofs like this that begin with negations.
Hi.
Okay, say hi.
Hi. Pooty doody.
Okay,
Hi.
very good, thank you.
Have to learn about me.
Yeah, right. Okay.
Everybody is me.
August wants to say hi. Say hi, August.
Hi, students. Good luck in the exam.
Good.
Good luck in the exam.
Yeah, okay, very good. Sorry
Have
about
fun.
that. Okay. Coronavirus. Trying circumstances. All right, quiet now, guys. I'm lecturing, please. All right, so the first thing you have to grasp when you're presented with a proof like this is that these are negations. They are not in quantified form. Okay, so anticipating Unit 15 stuff, there are 4 rules governing the use of quantifiers. 2 of those rules, they're called instantiation rules. It'll be universal instantiation and existential instantiation. These rules allow you to move. They allow you to move from statements that are in quantifier form to an instance of that, that is, to a formula which is, as we'll see, in truth functional form, right? So, for example, from a universal statement to a conjunction or a disjunction, or whatever the major operator of the propositional function that's bound by the quantifier in the quantifier statement, the instantiation from that quantifier statement is going to be in whatever truth functional form that is, right? I'll show you how that goes in a second. It'll be easy to see when said less abstractly. And there are 2 rules that usually used at the end of the proofs called generalization rules, universal generalization, and existential generalization, which allow you to go from a truth functional statement to a quantifier statement. So think of it like this: instantiation rules, you're dropping quantifiers, going from, so usually used at the top of the proof, going from quantifier statement to a truth functional statement, right? So from a universal statement to, say, a conditional, and then when it's a conditional, then it's ready for modus ponens and modus tollens, right? So you'll be doing truth functional reasoning after the instantiations. Then you'll have, as a result, a certain truth functional result, say a conjunction, and then you'll use the generalization rule to get it back to, don't touch the computer, guys, get it back to a quantifier statement, because your conclusion will be something in quantifier form. Stop, please. Okay, so you've got, but when you see something like this, right? Eden, please stop, okay? When you see something like this, you have to say, the first thing I have to do, right? None of these formulas are in quantifier form. They are rather negations, right? So here I have to pull out, I have to transform these formulas into quantifier form, right? How do I do that? So that's where you have to pull out the quantifier negation equivalence rules, or in this case, the categorical quantifier negation equivalence rules. QN rules, quantifier negation, we learnt them in Unit 11. Categorical quantifier negation equivalence rules, CQN rules, so we'll be citing CQN here. You learned them in Unit 12. We'll have to use these both here and also we're going to have to transform this one, working backwards, into something that's in categorical form, by CQN, such that our premises and conclusion, or rather formulas that are equivalent to our premises and conclusion, right, are in quantifier form, so that we can use the instantiation rules at the top and the generalization rules at the beginning to derive those formulas. Okay, so I'll do this proof, and I'll start with part 2. Let me talk to my kids for a minute, and then we'll start doing this proof in part 2. But the big point of this introduction was to motivate the lesson from Unit 14. The big lesson from Unit 14: learn to distinguish quantifier statements from formulas not in quantifier statements. When will we be using that knowledge? In proofs with stuff like this, when you're faced with premises and conclusions which are negations but are just one CQN or QN away from a statement in quantifier form. And you always want to aim towards getting in quantifier form so that you can use the instantiation and generalization rules. So part 2 will come back and we'll do this proof.